Okay, here we want to look at how we use a matrix to solve a linear system. Now remember, if we're trying to solve for one variable, we can pretty much use a regular linear equation to solve for x. If we have two variables, we'll pretty much either use the elimination method or the substitution method to solve for x and y. But when we have three variables, four variables, five variables, or basically just large systems, generally we want to use a matrix. Thankfully, we have technology now where we can insert it in technology or use programs, but we do want to have a common general knowledge of the matrix. So here we have x plus y plus z is equal to 2. 2x minus y plus 3z is equal to negative 7. And x plus y minus z is equal to 6. So the first thing we want to do here, we want to write what's called an augmented matrix. Now, with the augmented matrix, what we're going to do is use our coefficients and write our matrix out with the coefficients and what's called the solution vector, as we can see it. All right. So now we have this matrix, and we'll see what we do with it. Now, the idea when we have this matrix, what we want to do, we want to get it in what's called a row echelon form. We get it in a row echelon form so that we can use back substitution and then solve for z and then y and then x, or z, y, x, w, and just with however many variables that we have. So now, one thing that we'll do, and we'll see how to put this in row echelon form. First thing we want to do, we want to make this a 0. Now, there are a lot of different ways to do these problems. Row echelon form is not unique, all right? But for me, I like to push myself down, work myself down, and then work myself back up through back substitution. So let's see what we mean here. So the first thing I want to do, I want to say negative 2 row 1 plus row 2, and that's going to give me a new row 2. All right, so let's go through this one. So this stays the same. 1, 1, 1, and then 2. Now, negative 2 row 1 plus row 2. So negative 2 times 1 is 0, plus 2, that gives us a 0. That was our desired result. Negative 2 times 1 is negative 2, minus 1, that gives us a negative 3. Negative 2 times 1 gives us a negative 2, plus 3, that gives us a 1. And then negative 2 times 2 is negative 4 minus 7, that gives us a negative 11. So that's what we're looking at. We can check over here. All right, and now we still have 1, 1, negative 1, and then 6. So now we'll just continue to move forward. Let me clean up everything here. All right, draw our matrix. All right, and we want to move forward. The next thing we want to do, we want to look at, okay, how do we move to the next one? Now we want to make this one into a 0. All right, so what do we want to do? We want to say negative 1. Let me put this in red. We want to say negative 1 times row 1 plus row 3, and that's going to give us a new row 3. All right, so let's come back. It takes time to do this, and we have to be very accurate using our mental math. See, we're not bothering row 2. We've already worked with that one. So now, -1 times 1 is -1. That gives us a 0. -1 times 1 gives us a -1. That gives us a 0. -1 times 1 gives us a -1. -1, that gives us a 2. And -1 times 2 gives us a -2. A 6 gives us a 4. So now, if we can look at it, we've already gotten this into row echelon form. Just in 2 steps, we've achieved row echelon form. And let me go back and through and show you exactly what we mean. Yeah, sometimes it'll take a few steps, sometimes it will take a lot of steps. But what we want to do is make sure we have a system to move. Let's see what we mean. We have a 0 here, okay? And then on the next row, we have 2 zeros. If there was another row, we would have 3 zeros. If there was another row, we would have 4 zeros. And you can see this little triangle that it makes, but it's ready for back substitution. So this is what we're going to say. -2z is equal to 4. If -2z is equal to 4, that means z is equal to -2. Okay, now we're going to work ourselves back up. We have -3y plus z is equal to -11. Okay, I have -3y minus 2 is equal to -11. -3y, add 2 to both sides, that's going to give us -9. -3y divided by -9, y is equal to +3. And now I'm going to move up here just to make sure I have room. All right. X plus y plus z is equal to 2. I moved up to my first row. I solved for and I solved for y. Now let me move up. That is x plus 3 minus 2 is equal to 2. X plus 1 is equal to 2. We're just simplifying everything. Remember, 3 minus 2 is equal to 1. And when we subtract the 1 from both sides, x is equal to 1. Okay, so our answers in this case are going to be 1, 3, -2. Remember, we're not trying to just solve for one variable. I'm sorry, for one equation. We're trying to solve for the entire system. So we can look back and check this out. Let's look at it. 1 plus 3 is 4, and 4 minus a -2 is 6. Okay, 2 times 1, 2, minus 3 is -1. -1 minus 6 is -7. Okay, and we have this one, 1 plus 3 is 4, and then 4 minus 2 is equal to 2. So we've solved this entire system, and our solution is 1, 3, -2. But the main thing here, we have to make sure that we get this row echelon form, okay, where we have zeros up under our leading entry. Below that, we have 2 zeros. That's what's going to allow us to use back substitution.